I get the impression that everything is an evolution of Stardust, which makes me wonder, what does future evolution hold?
It is the richness of the chemistry that the periodic table of elements grants us. As far as I can tell, it knows no bounds. The water molecule, H2O, you break it apart, the hydrogen joins something else. The oxygen joins somebody else. You're breathing oxygen atoms that were exported by a star 5 billion years ago. Feel it. Feel that connectivity.
Feel the burn.
Feel the burn. This is StarTalk. Neil deGrasse Tyson here, your personal astrophysicist. Today we're doing Cosmic Queries Grab Bag Edition. And I've got co-host here, Paul Mecurio. Paul, welcome back.
Great to see you.
Oh,
Great
I love your work, man.
Thank you.
Yeah, I see you on the Late Show.
Yeah.
The occasions when I'm on, I see you warming up the crowd.
Yeah.
But he occasionally gives you a slot.
Oh,
in there.
yeah. I've been on a bunch of times, and I'm going to be going on again very soon.
Okay.
Doing
No,
another set
cool.
of
We'll look for you.
stand-up. Yeah,
We'll look for you.
It's always great. Yeah.
And you got there's like a Broadway show or a stage show, Permission to Speak, and we all know your podcast.
Yeah. Inside Out with Paul Mecurio.
Inside Out with Paul Mecurio.
And you're on it.
I think I've been on that a couple times.
Yeah, absolutely.
All right.
I still owe you money for that.
So there's no categories here.
There's no categories.
Right.
This is loose, but I got to tell you,
and you got pages and pages, dude.
We got tons of, and they're all good, and they're varied, and they're from people all over the country and all over the world, and different age ranges, which you'll see in a minute.
Good.
So it's really cool.
Hit me.
So this is Mancheno. Cheno from the US of A.
Mm-hmm.
Had the SSC in Texas gone through, where would we be today? Do canceled projects like this set us back as a species? Also, what other major scientific breakthroughs have been made or halted?
Ooh, made or halted. I like that.
Sounds like he's digging.
Yeah. So the SSC, the Superconducting Super Collider, which was, had I been in charge of naming it, I would call it the Super Duper Collider.
I was going to say, I think it needs more adjectives.
That's what I know.
The gargantuan super.
They ran out of adjectives
Oh
there.
my God, honey, look at the size of this collider.
Yeah, so they missed out on that one, I thought. If you take certain metals and you reduce their temperature, there comes a point where they become superconducting, where electricity can pass through them and there's no resistance and they don't get hot and it just moves. We call that superconductivity. In the 1970s and 80s, there was research into, can we make superconducting materials at a higher temperature? In other words, as you lower the temperature of the material, can it become superconducting at a much higher temperature than previously enabled?
Why is that important to seek it at a higher temperature?
Because if you can find a room temperature superconductor, that would transform everything.
Yeah, but then every average person is going to have it, and then we're going to have all these
power.
people with superconducting.
With superpowers.
And then all of a sudden, people are going to be turned into like little ants, like Ant-Man. What are you people, crazy?
Is that how he became an ant?
You guys can't put power like that in a hand.
Okay, that's a very good point.
You want to meet my brother-in-law? You don't want that guy having...
It should have some guardrails, right?
Okay.
So it came of age when higher temperature superconducting materials were becoming available. And why does that matter? For any collider, you're accelerating particles. The particles have an electric charge. And if you move an electric charge through a magnetic field, you can accelerate it.
Okay.
And you adjust the magnetic field, make it just right. It can get very, very fast. The particles can go very, very fast, hitting 99% the speed of light.
And what does the manifestation of that very fast moving particles look like? Is that the electric? It's
just a beam of particles, like typically protons, and you slam it into a target.
Okay.
And that creates a field of energy out of which brand new particles can form.
And we harness that energy.
No, it's not for energy. It's for what new particles exist in this universe that we didn't know about before we turn on the switch.
Oh, we have enough particles. Why do we need new particles?
Because you always want more particles. Come on.
What are you doing with the new particles?
We need more because a new particle might explain something we didn't understand.
Oh, okay. So you're constantly in search of.
Yeah.
It's like what we were talking about on another show. So you never
probing the universe. Rest. Yeah, you never rest. So it came of age at that time, and by the way, it's still the Cold War, early 90s. So under Reagan, we say yes, let's start this project, Superconducting Super Collider. They dig the hole. Oh, by the way, it would be the largest and most powerful super collider in the world.
You dig a hole somewhere out.
Yeah,
in
it's
the
like, I
desert.
forgot the diameter, a couple of 100 miles. I mean, huge.
Yeah, it's the Meadowlands. That's what they did it.
Some states are not large enough to contain this collider, such as Rhode Island. All right.
Which is where I'm from.
You're from Rhode Island.
That's my home state.
You can't.
Can the world stop making any small reference and compare it to Rhode Island? Can we all move on from that? If I hear blankety blank twice the size of Rhode Island, I'm going to create my own super collider and zap you. Okay.
I didn't know it was that sensitive. Rhode Islanders carry
Yes.
issues.
Yes. We have size issues.
You have issues.
As it were.
Okay. So Texas clearly big enough. So it's in Waxahachie, Texas. Okay. They acquired the land, started digging the hole,
Right.
and the years go by. And around 1989, 1990, the government takes another look at the contracting, the budgets, and they judge that there are cost overruns that we cannot afford. And they zero the project. That's different from canceling it,
Now,
but it's the same thing.
From what I read, the project was fairly far along.
Yes,
too.
it was. Yes, it was. The research, the engineering, and then they zeroed the project. And once that happened, the center of mass of particle physics would no longer be in the United States. But just because you don't do it doesn't mean some other folks can't or
Right.
won't.
Right.
And the European Center for Nuclear Research, CERN, which is located in Switzerland, but it's a European consortium, an international consortium, I should say. They said, all right, you're not going to do it, we're going to do it. So then they built, as part of their facility, the Large Hadron Collider. You might have heard of that, the LHC.
Mm-hmm.
That became the detector that found the mythical Higgs boson, the God particle, the particle whose field grants mass to other particles. That's badass. If you're going to be a particle, that's the particle you want to be.
You want to be.
And so there's a book called The God Particle,
Yeah.
written about the Higgs boson. That was
Right.
written decades ago.
Right.
Because we knew that it should be there.
Right.
We don't have an accelerator that can detect the energies where we would find it.
Right.
So
And that's the particle that kills its brother, the other particle, who thinks he's cheating. He's Fredo. He kills his brother Fredo. Oh, I'm sorry, I got this mixed up with the Godfather. Go ahead, continue. I'm a little.
So
In all seriousness, why couldn't the scientific community in America convince the federal government and the people funding this that this was a mistake?
because they didn't call it a super duper collider. That's my answer.
those idiots would have understood the significance.
Okay, so watch. There is a report that talks about the
Yeah.
budget that we can't afford it. I have a different view. No time in the 20th century, when we had the power to make particle accelerators, did anyone complain if there were cost overruns. You don't even know if there were cost overruns. Maybe there were no cost overruns. I didn't check the budget on every single particle accelerator in the country in the 20th century. There's Brookhaven. There's Stanford Linear Accelerator. There's outside of Chicago, Fermi Labs. Okay, all over the country, and they're all under the auspices of the Department of Energy, by the way. So a budget serves this. All right, this gets canceled. Wait a minute. What else happened in 1989? Peace broke out in Europe.
Yeah.
Peace broke out.
Right.
The Berlin Wall came down. And within 4 years, the Soviet Union was dissolved. Oh, there was cost overruns we can't afford.
Politics.
If you're threatened with your life and your way of living,
Right.
there are no cost overruns.
Right.
That's not.
And how can That's exactly right.
Okay, I don't mean to I'd be blunt about it.
right,
Okay.
right.
So
Here's a blank check. Keep me alive.
keep me alive. Yes.
Right?
Keep me alive. And by the way,
Very clever to put it under the auspices of the Department of Energy instead of the DOD, so that it can look like it's.
it looks like just a science project that we don't.
We're going to better our
afford.
energy out.
Correct.
Whatever.
Correct. But 20th century was the century of the physicist, from beginning to end, all the way through.
Yeah.
And no Cold War. By the way, President Clinton comes in the 1990s, and it's the first time that anybody remembers the budget is balanced for the United States. And so they want to take credit for balancing the budget, except there's no Cold War anymore. Okay.
Right.
So he takes office. There's no Cold War. So
yeah,
let's be real about budgets.
Right.
All right. Let's
Right.
understand this.
right.
And I write about this. It's speculative. There's no document that says this. The document says cost overruns, we're zeroing the budget. We have other priorities. There's others that said that when the space station was coming online, the space station would be primarily served through NASA Houston.
Right.
Okay, the Johnson Space Center.
Mm-hmm.
Others declared that the politics of it were you can't have two major projects in the same state that would get that much attention from the government.
Yeah, but you can move one to another state.
No, you can't move the hole in the ground, the
Oh, you
accelerator.
move the other.
No, Johnson Space Center, you can't move that.
Put it to Florida. Do it to Florida.
No, Florida already has a space center. But that's not where the
See, it's this
astronauts...
kind of negative thinking that kept the super duper collider from existing.
At Florida Space Center, they don't train the astronauts there. The astronauts are trained in Houston. NASA has 10 centers strategically put. All right? This is...
Listen, my friend, you just said it a minute ago. If we were on the verge of a brink of war, they'd find a way to have
there are
both
no
of those
cost overruns.
They're both of those programs to exist.
So I wrote about this in my book from a few years ago. When was it? 2017.
Mm-hmm.
Accessory to War, the unspoken alliance between astrophysics and the military. And I talk about this two-way street between the frontier of modern astrophysics, particle physics in there as well, because particles we learn about the Big Bang, and the needs of the military. So that became the most obvious accounting for that to occur. We lose the center of mass. It goes to Europe. Europe eventually discovers the Higgs boson. Nobel Prizes all around. Our accelerator was, depending on the beam, 3 to 6 times more powerful than the most powerful settings of the LHC. So we would have discovered the Higgs boson decades ago.
And perhaps either at that time or in the resulting decades, other things.
Oh, thank you. Other things, perhaps other things.
Right.
But once you get there, now you ask the next questions.
Right,
It's
which
a new
is
place to stand.
you never stop,
and you have
right.
a proscenium
Now
looking
you're
beyond
out what else is out there.
exactly.
Right.
It's never about the question you even know to ask.
So
It's the question you haven't thought of yet.
Right.
Because there's a place you will soon stand that will give you a view that you didn't even know was possible.
And based on that perspective, the setback is almost exponential in a way, right?
Well,
because
no,
we
no.
don't know what we don't know,
No.
and that's the shame.
You don't know what you don't know. Correct. And that's deep and important and real. They're trying to boost the energies of the LHC to go to the next level there. So that was getting back to the specifics of the question.
Yeah.
The discovery of the Higgs boson was delayed decades because of that decision. But science is science. It's not about the creativity of an individual. If Beethoven did not compose the Ninth Symphony, if Van Gogh did not paint The Starry Night, no one who will ever be born in the future will compose or paint that.
Right.
Whereas in science, you can be very creative and be ahead of everybody, but eventually everybody catches up and we move beyond it. Because what decides what is true is not the public's voting on, oh, we like your artwork. It's nature, which is the ultimate judge, jury, and executioner of your idea. And if you don't want to do it in the United States, another country does it. By the way, it's international. So we had Americans who were part of that collaboration, but we didn't lead it. That's all.
Yeah.
And I'm American.
America.
I'm a 20th century American when we led everything. And now I'm going to, oh, what you got over there, guy? Can I look over the fence?
I had that.
We almost had that.
It's like you're looking over the fence and your neighbor's got an in-ground pool and you've got an above ground. We're the country. America's a country when it comes to that with the above ground pool. Well, that was a great question.
Okay,
and a tremendous answer.
I gave it a long answer, but it was
great.
Hey, StarTalk fans, I don't know if you know this, but the audio version of the podcast actually posts a week in advance of the video version, and you can get that in Spotify and Apple Podcast and most other podcast outlets that are out there. Multiple ways to ingest all that is cosmic on StarTalk.
I love this person. This is Rupesh. Hi, my name is Kriti. I am 11 years old. I'm in the 6th grade. I live in Cary, North Carolina. In my school, we are doing a passion project, and my topic is astrophysics, as I find this topic very interesting. I have also recently been
This person's
reading
11 years old?
this. I know, right? Been reading.
No, you're lying.
It's,
So it's not 22 or...
no.
Okay, fine.
It says 11. I know how to read. I've also been reading your book, Astrophysics for Young People in a Hurry. By the way, could you come up with a longer title? Jesus. I have a question for you, and I'd love if you could answer it for me, as that question would be added into my project plus your answer. So speaking of truth, this kid's asking you to help her cheat. Here's the question, very basic. What existed before the Big Bang?
Oh, I can answer that.
You can?
Yeah,
Really?
yes.
Okay, go ahead.
We had no idea. Okay. Next question.
This is why people find scientists annoying.
But no,
We
what?
want some
Don't generalize
we want
to
some-
everybody else just because
We
you...
want some definitive answers in our life.
Just because in this moment you find
I can answer it.
me annoying.
Here's
Don't
I
generalize
got
to
two
everybody
things
else.
that existed before the Big Bang. You
What?
ready?
Yeah,
Lint
maybe.
and a single sock. It started all with a single sock
Is that the
floating
sock
around.
that is missing from the laundry?
That single sock
It's
is
lost in space
floating around in
and in
space.
time.
In time.
We don't know for sure, and we wouldn't even know how to experimentally verify our ideas. But there are some ideas. And when you run the equations back through time of general relativity, Einstein, and quantum physics, by the way, we are in the centennial decade of the discovery of most of the important tenets in quantum physics. So I feel it gives me
Yeah.
goosebumps,
Yeah.
actually. And not only that, that's the decade where Edwin Hubble was a person before it was a telescope.
Before a telescope that didn't work.
It works now.
Was he as defective as a person as he was as a telescope?
His mama didn't think so. So in the mid-1920s,
Right.
he discovers that the spiral fuzzy things in the night sky, spiral nebulae, were whole other galaxies, like the Milky Way. This is freaky.
Was there speculation as to what it was before he
Just spiral clouds.
Yeah.
There were other fuzzy clouds that weren't spiral. So they were like...
But there were telescopes that existed before his.
No, but you have to know the
not
distance
power.
to things.
Right.
You can't just pace it out by walking it. All right. If you find the distance to a spiral nebula and it's 100 times farther away than other nebulae, then it's sitting outside of your galaxy.
Right.
All right. And so that he discovered that in mid-decade. And then by the end of the decade, he discovers the expanding universe. That 1920s.
Yeah. It's
the
a lot.
roaring 20s.
Yeah.
Right before the market crashed
Right.
in October 1929.
And then, people weren't so focused on science, unfortunately. It's like the science of eating and having food on your plate.
When you run the equations back, you generate this entity that pumps out universes, possibly an infinite number of universes. It just pumps them out. And we call that the multiverse, a term that's just been uptook
By Marvel,
by Marvel
comics.
And not only Marvel, but of course, Rick and Morty.
Right. With all of these brilliant minds out there over the years, what is your theory as to what's keeping us from knowing what existed before the Big Bang?
We've been figuring out other things, like the origin of the Earth and the origin of the moon and the origin of stars and and now we're on the origin of galaxies. So the origin of give us a chance here. We have top people working on it.
Yeah, but you're avoiding the question.
Yeah,
Like, I'm having an argument with my wife. You're avoiding the question.
Stop. What I'm saying is science is more about knowing what question to ask than to have an answer for every question posed. Isaac Newton, my man, here's my little finger puppet of him here next to my voodoo thing. I don't even know what that showed up in my office one day. I don't know where it came from.
That is a little creepy.
Yeah, I have no, this was just in my, I don't even know where it came from.
This thing's got to put some weight on. A little malnourished.
We'll sit him there. Isaac Newton, in his book Optics, published 1704, wrote it in English so that like regular people could read it, not in the academic language Latin for scholars. At the end of his book, he has a section called queries. By the way, that's where I get the word cosmic queries. It's not called cosmic questions. Which would also kind of work. You get the alliteration, but cosmic queries. He has a section in the back called queries.
Yeah.
This is just stuff that spilled off his dinner plate. One of them is, I wonder if the stars of the night sky are just like the sun, except much, much farther away.
Wow.
Yeah.
Wow.
Okay.
Yeah. And that's like a scrap off the dinner
Off it.
plate.
And,
Wow.
and this is the guy who utters this line. I'll mangle it only a little. He says, sometimes I feel like a child sitting on a shoreline, picking up one pebble for being shinier than another, when an ocean of undiscovered truths lay before me.
Wow. Mm. So
It's Newton saying that,
is it,
a man. So anyhow, so the multiverse is there for what might have been around before the Big Bang, and but that just moves the question back. You know, where'd the multiverse come from?
yeah, it just keeps
Yeah.
going
So
and going and going.
that plagues origins questions.
Right.
And by the way, it somehow doesn't plague religious people.
Well, I was just going to say it's sort of, we're not even talking about the theory that God created everything, and yeah, there is, it's not science.
Well, it's not a theory;
right,
it's faith
right,
that says
right,
that.
right, yeah.
So what intrigues me is when I say, "Well, I don't know what was around before the Big Bang." Something had to be there. Something.
Yes.
I said, "Well, we got top people working on it. We're working. Give us a chance." It had to be God. Then I say maybe the universe always was. No, it had to have a beginning. And so it's okay. Well, so what do you say? Well, it was God. And so then I say, well, who created God? Oh, God always was. God was always there. So they allow that within themselves to say God always was, but won't allow the scientists to say maybe the universe always was. Apparently that's not allowed.
Right.
But it's allowed when you're religious and you say it about God. So all I'm saying is the origins questions will always be able to push it forward unless somehow it creates itself. And then you have a loop.
Right.
But we're not there yet. It's a frontier.
Right.
Give me some more.
Yeah, you got it.
Grab me some more.
Yeah, this is Umar Chima. Umar from Seattle. Longtime StarTalk listener. I finally decided to get off my cheap ass and become a patron.
I love that.
Yeah.
Thank you, Umar, for getting off your cheap ass.
Okay.
Okay.
Yeah, save your money because T-shirts are coming. Patreon Saints.
Patreon Saints.
Here's my first question. We know that we can slow down our time relative to others by traveling at a super high speed or getting very close to a massive object in space. But is there a way to accelerate our time instead of slowing it down? Can we accelerate our time and essentially visit the past, or does it just mean we just get old super fast? And if anybody knows about getting old,
see, I'm proud of my age.
you should.
I'd like to believe that I have wisdom to show for it.
You do.
That's all. Because I don't want to get old. I don't want to get old. Yeah, because they're not learning new things.
Exactly.
They're stuck in some previous time in their lives.
I agree with you.
Where they wish they were still on the football team or still on the cheerleading squad. When
speaking of which, that's why I don't want to go back to the past, because I'm not going to ever win that 50-yard dash and then embarrass myself. I couldn't get Mary Ferguson go to the prom with me. Don't get me started. Oh, okay.
Man, you have issues you're bringing to the show. Okay. You got to leave those in therapy.
I can't. This is why I'm here. I need you. So can we accelerate our time and visit the past?
I think you have to look at it differently.
The guy's a paying customer. He can look at it any way he wants.
That's true. Customer's always right. Okay, you're right.
You're right.
Whatever you're thinking, you're right.
Just keep sending the money, people. Come on, send the money.
You shouldn't look at it that way. You should look at it as your speed as seen by others. By the way, you don't feel this at all. It's only as measured by others. So if you go fast and time slows down for you, you're still ticking. To you, it's 1 second per second. To everybody else, it's 1 second per 10 minutes. 1 second per hour.
I'm not following it. Explain it. How is it observable by others, my speed?
If I see you, so I'm here, and I see you whiz by at some speed.
Okay. You see me walk down the hall.
Well, I was thinking of a rocket ship, but sure.
Okay. All right, a rocket ship.
Okay. Walk down the hall at half the speed of light.
Okay. Which I can do.
All right. I have an equation, a formula that tells me the rate at which your time is ticking relative to me. And I plug it in, and I forgot the number. It might be ticking a third or a fourth.
Well, my time is different than yours because you're stationary and this thing is moving, no?
That's almost the right way to say it. Your time is different from me because we are moving relative to each other. As far as you're concerned, you are stationary, and I'm moving past you at half the speed of light. We don't know.
Right.
So you will look at me and say, oh, he's moving slow. And I look at you and say, oh, you're moving slow. Both of us will measure the same thing about each other if we are passing each other in the night at half the speed of light.
One going one direction, one going the other
Correct.
direction.
And so...
Why is half the speed of light a critical...
It's not.
It just
I could
be
say
whatever.
10%, but it's not linear, so the faster you go relative to the speed of light, the greater and greater the effects are. All right? So half the speed of light is not half the effects.
Okay.
It's a small fraction, and it grows rapidly.
Okay.
All right? It goes at like the square of your velocity as you get closer. How do I make your time go slower if you're going half the speed of light? I make you go faster. Now you go 3/4 the speed of light, 90% the speed of light. And I can watch you slow down relative to me. How do I speed you up? Go slower. Go 1/4 the speed of light, 1/10 the speed of light. How slow can I get your time to go? Stop right in front of me. And that is the slowest we can make your time go.
Which is the same time.
And that happens to match my time. Correct.
But
They want to go backwards. We don't know how to do that. Because I have to repeat my time poem.
Please.
If I may.
Please.
We are prisoners of the present, forever transitioning between our inaccessible past and our unknowable future.
That's exactly what I say to my wife when she asks if I bought pickles and I forgot.
You know, you're bringing your issues into...
Well, you make it very relatable to my life.
Okay.
And I have a lot of issues. And, you know, I love you, man. I love you. So the answer is...
It's not your fault. It's not your fault.
But there's this obsession in pop culture with this time
We
travel.
want to go backwards in time.
And do you think, do you just think, and
It's-
I know, I
it's
love you never
dangerous.
say absolutes, but like, why? It's dangerous because you start flirting with the past and you alter the future and whatever.
Well, you can flirt with your own future.
So if you went in the past, what would you change?
You have to watch out for that because you don't know the full set of contingencies that would follow.
Okay, who cares about anybody
No,
else?
they do
What would
because you
change
say
for you?
if you go in the past and there's Hitler as a child, will you kill Hitler as a child? Would you do that? What you don't know is there's someone else that would rise up that would have been worse than him for the stability of the world in the 1930s and 40s. You don't know that.
Right.
I'm keeping the past the way it is, not knowing whether having altered it. By the way, this was explored in an episode of Star Trek. They went back in time to the 1930s or late 30s. I forgot the exact year. And Bones, I think it was Bones, the surgeon, falls in love with a woman. You're not supposed to do that because they're
you're messing with
the time the space-time continuum.
But as usual, men led by their whatever. That's a scientific fact. That is a scientific fact. Go ahead.
No, on that subject, by the way, the first interracial kiss between a black person and white person was on Star Trek, and it was William Shatner.
Oh, I remember that.
It was kissing Lieutenant Uhura.
I remember that.
Okay, they got all kinds of hate mail from the South on that. They could. It was 1967, somewhere around there.
Right.
Meanwhile, Captain Kirk can visit all these galaxies. There's a green woman, a blue woman.
She's got a tumor over here, a horn over here.
He kiss them. They're clearly female aliens. Yeah. He's kissing all up in them. But another human who has skin.
He's kissing a woman that looks like a Kreller. That's fine. But not that black woman, damn it. We have standards.
Bones falls in love with this woman.
Yeah.
And she's She's into peace. She doesn't want war. She sees nations building up, and she tries to prevent the start of the Second World War. This is her motive and her mission. Meanwhile, she gets hit by a bus or a truck and dies. And Bones is distraught. He wants to go back in time again
to prevent
that, to save her. They go back in time again, and that's when Spock does his research. He realizes she has to die because if she lives, she will successfully delay the entry of the United States into the Second World War, giving Germany, Nazi Germany, the leg up in creating the atom bomb, and they create the atom bomb first and take over the world. And this is communicated to Bones, and the scene where she's going out into the street and the truck is coming, he wants to save her, and and Kirk and they hold him back.
Yeah.
And they just watch her die.
Yeah.
Because that's a different world that they don't want to have happen.
Right.
So, stay in the present. Get your ass out of the past.
Okay.
Okay.
That sounds good.
Oh, by the way, Hawking has a time travel conjecture where he says he thinks that as we get closer to traveling through time, there'll be some new law of physics that we will discover that will prevent it.
On the subject of Star Trek, can you explain to me why when they transport Kirk, his shirt never fits properly? They can't make it so it's a little bigger. It's like he went to the baby Star Trek store.
Because it fits tightly? Yeah. Because he was a buff body back then.
I understand, but
not by today's standards, but back then he was. And plus, if of all the captains, he's the captain I'd want to be.
Why?
Because
the pointy sideburns.
I did give myself pointy sideburns in my day, but he took on all his own fights.
That's music.
You remember that? Yes. So the point is, if you are a crew member and your captain is fighting the bad guy,
right,
you're going to fight the bad guy.
Right.
You're not going to be like Jean-Luc Picard and say, go fight them. Get your own ass out there.
No.
It's like,
no, but there's another side to that. I don't want the guy leading to get in a fight and die. Like,
he's Kirk and he's got phasers. Don't worry about it.
I'd be like, hey, guy, I got to stay back here.
No, he's got phasers. We good.
Yeah, but he's got all the change to put in the meter when he's parking the ship in the middle of the thing. You don't know what you're talking about. I think he does have a good body. I'll give you that.
In the day, that was a good body.
Okay.
You think the transporter should have had a tail?
Yes.
He shows up looking down.
Yeah, exactly. Yeah, with a jaunty hat, a cane. Come on.
That's a different transporter. That's a more expensive transporter. The one that's also your tailor. Okay. Have you ever wanted one of your questions on the universe answered? We all have questions about the universe. From black holes to quasars, quantum entanglement, wormholes. There is no end to the depths of cosmic curiosity. Well, the entry level of Patreon membership with StarTalk gets you just that. I think it starts at $5 a month. You have access to the question line that reaches our Cosmic Query programming. And not only that, we produce a special Cosmic Queries installment just for Patreon members.
If you weren't the director of the Hayden Planetarium, what do you think you would be doing?
Okay, but this had to be another universe. It wouldn't happen in this universe.
Okay.
I'd be a songwriter for Broadway musicals.
Ooh!
So that's the entry level, and the perks ascend from there. There's a level, in fact, where we send you an autographed copy of one of my latest books. Right now, it's Starry Messenger, Cosmic Perspectives on Civilization. And it's signed with my fancy fountain pen with purple ink. So I invite you to just check the link below. And all of that money goes to our ability to experiment with new ways of bringing the universe down to Earth. So thank you for those who have already joined. And we welcome others to participate in this grand adventure of what it is to bring the universe down to Earth. As always, keep looking up.
And Emily Kaneko Reynolds. Hello, Neil. This is Emily in Kyoto.
Nice.
Yeah. Is there stardust in the air we breathe, or is the stuff in the air that air is made of just an evolution of stardust? I get the impression that everything is an evolution of stardust, which makes me wonder, what does future evolution hold? And I can tell you, future evolution, there will be a time when humans don't have to bend over to put their shoes on. It's called Skechers Future. Is this where we are now? That we have shoes, that people can't bend over to put their shoes on? Is Skechers a sponsor? I am so annoyed by this. Is this where we are now?
Well, okay, we invented automobiles.
I can't go all the way down there.
And flight and supersonic transport, and we went to the moon, and this generation makes...
Right. I don't have to bend over 3 feet, and I can put more weight on.
I think the baby boomers are getting older, but they've always been inventive.
Yes.
Because we went to the moon under the baby boomers' watch.
Right.
So we're making our lives easier, making it seem like it's better for everyone, but it's really just for ourselves. Okay?
Okay.
All right. Because we can't bend over.
Exactly. All right. So I get the impression that everything is an evolution of stardust, which makes me wonder, what does future evolution hold? Now, this is evolution could be in the context of astrophysics or biological evolution.
All right. So allow me to clarify a couple of things.
Mm-hmm.
I speak glibly that we are not only poetically, but literally stardust. We are made of ingredients that were forged in the hearts of stars. Not all stars, this kind of stars that in their end of their lives explode and become supernovae, scattering their enriched guts across the galaxy. I was going to say contaminating, enriching other gas clouds with the ingredients of life itself. Carbon, nitrogen, oxygen. Go all down the periodic table right to iron.
And these are particles that are smaller than the diameter of hair.
They're atoms. Right? They're atoms.
Mm-hmm.
Okay? So I've loosely called it dust because these atoms gather and they make larger molecules. Dust has a specific definition in space. We speak of dust in space. So dust are agglomerations of molecules that are stuck together but are not chemically connected. You could pull apart the dust to get raw molecules.
Right.
You pull apart the molecules to get atoms. I'm saying the foundations of this are elements on the periodic table. And I loosely call all of that dust. So if you inhale dust from your shelf with the whiffer poofer, what do you call that thing?
yeah.
Swiffer poofer?
The whiffer pooper.
The pooper scooper? Don't you want to mix those two up?
The whiffing poofers, that's the
whiffing
Yale
poof.
choir.
Oh, the whiffing poofs. The Yale
Pooper
Glee
scooper.
Club.
Yeah.
Okay, the Swiffer.
If you hire the Yale Glee Club to dust your house and dust is generated, go ahead.
The Swiffin poofers.
The Swiffin.
So if there's dust and you inhale it, yeah, that's like household dust,
Right.
which commonly is like pet dander and other things. Yes, if you get to the bottom of that, ultimately those ingredients came from stars and from the origin of the universe. So it's not an evolution of dust so much as dust taking on other shapes. So when I say we're made of stardust, the actual dust from stars has been processed here on Earth.
Mm-hmm.
But it's still the same ingredients, the nitrogen, oxygen, carbon.
Right.
And so if I were to be more sort of chemically accurate in my discussion of dust, that changes the whole conversation. Hannah Holmes wrote The Secret Life of Dust, From the Cosmos to the Kitchen Table. Great title. A former science editor with I think the LA Times. But anyhow, so dust it's everywhere, you know. But rather than look at dust and say, oh, this is cat dander and this is from sawdust, I as a cosmologist, as an astrophysicist, it's all stardust to me.
And so
and in that famous song, was it by Kansas? All we are dust in the wind. And he says, all we are. It says, that's what we are.
But this human being that I am is stardust.
You are traceable to stars.
Okay.
And to me, that's a stardust memory.
So if
that I
we get
carry.
back to the question from Emily, I get the impression that everything is an evolution of stardust, which makes me wonder.
Which is fair. That's very fair.
So now her question is, what does future evolution hold based on this foundation of stardust that we just talked about?
It is the richness of the chemistry that the periodic table of elements grants us.
Got it.
And as far as I can tell, it knows no bounds.
That's the beauty of science.
The water molecule, H2O, you break it apart, the hydrogen joins something else. The oxygen joins somebody else. And there the universe progresses, unless it finds itself in a nuclear furnace. And then it'll can become another element.
Right.
But absent that,
right,
you're breathing oxygen atoms that were exported by a star 5 billion years ago.
Yeah.
Feel it. Feel that connectivity.
Feel the burn.
Feel the burn. I think that's all the time we have.
Yeah, I think
Unless you have a really fast one. Let's say a really fast one, and I'll give it a soundbite answer. Go.
Right, okay.
Really fast.
While a staple, this is Sparkman. While it's a staple, it's Sparkman?
Sparkman.
That's all I got. While it's a staple of mathematics such as calculus, are there any instances of infinity in the observable universe?
Ooh. Well, the universe itself might be infinite.
Yes, I have it. Neil explaining anything.
That's how long it takes.
That's the ultimate definition of infinity. Good night, everybody. I'll be here all week.
I don't get no respect. I try to.
No, it's a great question, though. Seriously.
So the universe itself might be infinite. If there's a multiverse, it's pumping out an infinite number of universes,
Which in each of which could be infinite of its in and of itself.
in its own dimensionality.
Right.
So, for example, I can have a sheet of paper that goes to infinity in every direction, but then I can have another sheet of paper floating above it that also goes to infinity, and they don't intersect.
Because they can go like this.
Yeah, because they coexist, but in a higher dimension than either of them. Each sheet of paper is only in two dimensions.
But aren't magnetic forces pulling them together in some way?
There could be, or even gravitational forces. And if you have two universes that collide, oh, you're talking about on Earth, the two actual sheets of paper. I'm talking about two universes
Okay.
that are infinite but not colliding with each other. If you embed them in a higher dimension, you can get away with that as you would with two sheets of paper. That's all I'm saying.
Right.
There are people, top people, wondering if there's a parallel universe, might we feel something of them, of their gravity? Is there some leakage out of their space-time that we might feel? That could be the future of detections of parallel universes, of the infinite universes. But my favorite example of infinity is Zeno's paradox, where you want to exit the door, you got to go halfway. Then you got to go another halfway. And then another halfway. You just keep doing that.
Well, wait, when I walk through the door, I walk through the door.
No, you're going halfway first. And then you're going halfway again.
Here's the door, here's me. How am I going halfway? I walk through the door and I don't stop.
Okay, you're being too rational here. You got to stay with the math, okay? You want to exit the front door. Before you get to the door, you have to cross the halfway point, don't you?
Halfway point of what?
Between where you happen to be standing and where the door is.
Yes.
We agree.
Okay.
Okay, now you got to cross the halfway point between there and the door.
Half. Okay, I got you.
And then the half and the half and
But
the
it's
half.
so
and the-
random to pick half. You could say I got to pass the point at the 1/3.
I-
The point at 1/3, one.
I could have. That's correct.
Okay.
All right. But, so there's an infinite number of halfway points.
Yes, I get it.
And Zeno saw this and said, by that reasoning, you'll never get to the door. Because it's an infinite, but of course you do get to the door. So what's going on? And what he didn't realize is that you are covering more and more halfway points in less and less time. And the infinity actually converges to a finite amount of time.
Right, because you're cutting down the distance. To
Correct.
The right.
And infinity can be cut into something that's finite. So, yeah, but other than math, no. I mean, the universe is finite to our observable edge.
All right. So there's no such thing as to infinity and beyond. I think that's...
You just dissed a book that I co-wrote with my producer.
No, that
Do you know the title of that book?
Yes.
To Infinity and Beyond.
Yes.
Yes. Why are you dissing the book?
No, I didn't remember that, actually. I'm referencing a Disney movie. Do I look that smart?
Paul, we got to go.
Yeah, this has been great. You've
Dude,
been fantastic.
thanks for
So
coming
great. Yeah,
back.
man. It's great to see you.
Yeah, man.
Love you.
Keep us smiling, keep us laughing.
Absolutely.
All right, and we'll find you on the road.
Permission to Speak, my Broadway show directed by Frank Oz. PaulMecurio.com for tickets. We're going to be in Dr. Phillips Center.
Mecurio.
Mecurio. Mecurio.
Like the SAT word mercurial.
There you go.
This has been StarTalk's Grab Bag Cosmic Queries from my office here at the American Museum of Natural History. Paul, thanks for coming in.
Thanks for having me.
All right.
Always fun.
As always, I bid you to keep looking up.